Welcome, everyone. My name is Ameya Jadhav. I'm the Executive Director of Teach Technology Organization, a 501c3 nonprofit organization, which teaches computer programming and machine learning to students. So my presentation today is going to be on computer vision in medicine and diagnostics. So there are 6 major things which I'll cover in my presentation. And if there's time at the end, we can do a quick question and answer session. So the first thing we'll cover is the real world applications of computer vision. Then we'll dive into what artificial intelligence really is, the history of AI, and then we'll go even deeper into deep learning and then computer vision. And at the end, there'll be a opportunity for extended learning. So the first real world example is something called the MySkin app. So the MySkin app is an app that I developed, and it uses computer vision and artificial intelligence to identify melanoma skin cancer. And I prepared a short video just to show you how the app works and how it works in action. So we'll go ahead and watch that video, and I'll just be talking over the video. So the MySkin app does inferencing and computer vision running for melanoma skin cancer. So a lot of different machine learning models and computer vision models are used in the app to identify melanoma skin cancer and then also not melanoma skin cancer. So when you look at this video, when you click camera, you can take a photo of my arm here. And then once you press done, you can see that the prediction at the bottom is coming from that computer vision model. So using this photo, we see 100% not melanoma in the red text at the bottom. So this prediction is coming straight from the image that is provided in the app. So this is an example of a real world computer vision application in melanoma skin cancer. So there are a couple other examples of computer vision in the medical field. And on the left here, we have the liver scans and then brain scans. We can see computer vision being used to identify liver lesions on the very left side. And then on the brain scan, some other objects and other things that the computer vision model is designed to identify. So that's what the red circles are. That's the computer vision algorithm actually identifying those things on those scans. And on the right side, we have another computer vision algorithm identifying another object in this scan. And it's just based on what these computer vision models are trained on to identify. So these are just a couple real world examples and how computer vision is actually being used in the medical field. But before we dive into a computer vision, let's get an understanding of what artificial intelligence or AI really is. So AI, or artificial intelligence, is a wide-ranging branch of computer science concerned with building smart machines or software that's capable of performing tasks that typically require some level of human intelligence. So AI is a very interdisciplinary science, which means it has very multiple approaches, it has multiple perspectives. But advancements in artificial intelligence and then the smaller subsets of machine learning and deep learning are creating a shift in virtually every tech sector or every tech industry in the sector, and also sectors outside of the tech industry. Really, in simpler words, AI is any machine or software program that simulates any human task that a human would usually do. So AI has been around as early as the 1950s, but it really wasn't a big field back then. And there are 3 main reasons why. The first one is internet with big data. So with the use of big data, we've been able to use and analyze big data sets, both structured and unstructured data, and actually use these for artificial intelligence and computer vision applications. So that was the one of the big milestones which really propelled AI to where it is now. Second, in 2007, NVIDIA released something called CUDA core processing for GPUs, and this changed how much time it will take for training these machine learning models. Previously, it took maybe days, weeks, or even months to train these machine learning models, but now they can be done much faster, and this is another big milestone. Third, then is new algorithms. So, and these new algorithms were enabled from the use of big data and the processing power that came from CUDA core processing. So, an example is in 2012, there was a CNN called a convolutional neural network, which we'll kind of discuss what that is at the end of the presentation. It was called AlexNet and achieved an accuracy that was much higher than the other accuracies for other algorithms at the time in 2012. And this was possible because of the utilization of the GPUs during training, which is again an essential ingredient of the deep learning revolution. So these 3 big milestones have really put AI, computer vision, where it is now that we see in the past decade or so. So computer vision really falls under a topic called deep learning. And deep learning also falls under a larger umbrella called machine learning. And machine learning is really the AI techniques used to enable machines to improve with learned experiences. And this machine learning concept also falls under the general artificial intelligence concept, which we mentioned is just enabling computers to mimic any intellectual human behavior. So just computer vision is in deep learning, and that's what we'll be talking about today. So there are three major types of machine learning, or types of how these machines can learn. There's supervised learning, there's unsupervised learning, and there's reinforcement learning. So supervised learning is a machine learning task of finding a pattern that maps an input to an output based on example input-output pairs. So a very common example is, let's say we had 50 images of cats, 50 images of dogs. We give those 100 images to our computer vision model, and then we say these 50 are cats, these 50 are dogs. So we're providing these example input-output pairs, and then we're letting the computer vision model understand how to recognize these cats and dogs, and eventually it'll be understand and recognize on its own. So that's an example of supervised learning, and deep learning is actually uses supervised learning. Unsupervised learning is another algorithm technique which is used to draw inferences from data sets consisting of input data without labeled responses. And then lastly, reinforcement learning is another area of machine learning concerned with how software agents take actions in an environment to maximize a reward. So a common example of this is the use of artificial intelligence in robotics, or even, I guess, self-driving cars. So this is kind of how software will take actions in a physical environment to maximize a reward or to reach any goal that's been set. So that's reinforcement learning. So this is kind of a visual of showing how the different applications and how the breakdown of unsupervised learning versus supervised learning versus reinforcement learning works. So if we look at the very top here, I've circled this image classification application, and it's pointing to computer vision. And that's because computer vision or image classification are just kind of synonyms of each other. And that falls under the classification task for supervised learning. So these are just showing some other applications that you can have for other algorithms or other types of learning in machine learning. But the main thing we'll focus on is that computer vision. So the big question is, what is computer vision? So computer vision is an interdisciplinary field that really looks at the methods associated with helping a computer or a software program learn and understand visual stimuli, just like a human can. So visual stimuli include things like digital photos or digital videos. Humans and computers look at these digital stimuli completely different, however. Computers look at them by looking at color gradients, edge detection, pattern recognition, a lot of other features that these are what they're called, features. And then humans, of course, look at it a little bit differently. But this is kind of how, on a very simple level, how computer vision works, and really the idea of computer vision. So in medical AI, there's a lot of applications using both just general artificial intelligence and also specifically computer vision. So first, data analysis. So this is just analyzing metadata or information to do some objective or do some goal. So these metadata and information can include like patient history, demographics, geographic location, and a lot of other factors. A newer and more common example is recently with COVID, they did data analysis where they can see who a person has talked to, who they've interacted with, what geographic location they were at, their patient history, infection rates, a lot of this other data, which really helps them identify a profile of who could possibly be infected. And this is just an example of using data analysis. A second major application of AI in the medical field is image classification, or just another name for computer vision. So this is the use of extensive medical imaging to provide better diagnosis, treatment, and the prediction of diseases. So for example, we saw in the very first example, the melanoma skin cancer computer vision model. So that's an example of using image classification in the medical field. We also saw the chest, brain, liver x-rays. That falls under radiology, and computer vision also used in radiology. There's a lot of other types of examples that computer vision is being used. If we refer back to that same COVID example, um, for CT scans in China recently, they actually were taking CT scans of the lungs, and they were using that as a way to diagnose COVID. So using those CT scans, they're using computer vision to find these different lesions or find these different indicators of an individual having COVID, and that was a way they could also speed up their diagnosis and for COVID-19. But besides that, there's a lot of other applications for computer vision. So with these applications, there are of course a lot of benefits that come about. Um, much of the benefits is that these computer vision algorithms are more efficient and faster when they analyze big data sets or multiple images. So if they're looking at different angles of the same scan, computer vision can do this much more efficiently and much more faster. Computer vision also works consistently all the time, and there's timely identification of diseases. So this quote here, I pulled from a study on using computer vision algorithms to detect lung cancer. And they say AI-aided detection helps radiologists to reduce the false negative cases and to detect lung cancer at an earlier stage. Computer vision also brings more precise diagnosis sometimes, and it helps minimize false positives and the false negative cases. And there's a lot of other examples with computer vision as well. So in computer vision, there's a lot of technical things, but a big concept that's talked about a lot is something called convolutional neural networks. And we mentioned this at the beginning of my presentation. So convolutional neural networks are mainly used in computer vision applications to analyze any visual imagery. So these are convolutional neural networks can be referred to as CNNs or even CogNets sometimes. And these are a class of deep neural networks. And you can see as examples of these on the graphic on the right here. So on the top, we have a biological neural network. So its biological neural network is kind of representing how a human mind works when it does image classification. So for example, we have an image of a cat there, and the human mind is looking at that cat, and then the neurons inside of the human brain, they form a neural network already, and they work that neural network and do a lot of different functions to identify what this image is. And then at the end, you can see on the right here at the top, it identifies that image as a cat. So this is kind of how a biological neural network works. And the goal of a convolutional neural network or in computer vision is to recreate this process of this biological neural network, but to make it in a software setting. So we can see if we start off on the left on the bottom here, the section B, you can see these different images of brain scans. Okay, and then these brain scans are compiled, and then they are taken as different segments. So these segments in this column here, where it says pooling layer at the bottom, these are pulled from the different sections of these images. And then this actual pooling or this different selecting these different segments that's what convolutional is, and that's why it's called a convolutional neural network, because it does this different selecting or these different segmenting. So by taking those segments, then the neural network can focus on these different segments and look at these different features in those segments. And then on the right here, this is actually how a neural network kind of looks visually. So we see these peach-colored nodes, or sometimes even called neurons, because they represent the human neuron. And then on the right, we see also green and then the blue nodes or the neurons. So these nodes and neurons, they connect and they make this neural network. And then they take these different images and they do these different functions, different mathematical computations, and a lot of other things to identify these outputs from these images. So, we have infraction, we have hemorrhage, and then tumor. So these are three outputs for these sets of brain scans. So this is kind of how visually a convolutional neural network works. And actually here we have a little bit more of a visual way. So on the right here, we can see we have, you can think of these as three different images, okay? These three different images. And then we have this little 3x3 blue section that's moving along and looking at only a smaller segment of those images. So this is how that segment happens, how it gets those different portions of that image. So it takes those different portions, and then this over here kind of represents that network section where it does different functions, different computational algorithms, and different mathematical computations on these different sections. and that's how it gets to these outputs. So, for example, this could be how it looks on when it's out looking at whether a image is a cat or a dog. This is kind of how a convolutional neural network work. So that's kind of a quick overview of convolutional neural networks. And if you're actually interested in learning computer vision using Python programming, my organization is actually teaching a machine learning crash course in partnership with deeplearning.ai. It's starting this Saturday at 10 a.m. EST, and it's completely free, and I'll be the one actually teaching that course. Only thing is that participants are required to have previous experience in Python, and there's more information and registration at that link. And the link is here again as well. So this is just my quick contact if you want to reach out to me with any questions or anything. And then that's the link again for the course registration and more information. And then we have a couple minutes left in my session, so I can take some questions. So I see a question. Do you think that AI will get so advanced that it will take over radiology jobs completely? I think a lot of radiologists don't only do the actual identifying these images, they also have other uses such as like talking with patients, more of this qualitative things that maybe AIs can't do. So maybe I see in the future radiology might be enhanced with the use of AI, but there's also going to be some role that radiologists will play to help support that system. But I think AI will actually help enhance their role as radiologists. Where did I get my data images in order to train my machine learning models about identifying skin cancer? That's a great question, Chloe. So to train my model for identifying skin cancer, there's actually two publicly available and anonymized data sets I use. One is called the International Skin Imaging Collaboration Archive dataset, and another one is the Harvard Dataverse HAM 10,000 images. So those two data sets, I use those two, I compiled them. There's about, I think, 44,000 images there. And I use that to actually train the models to identify skin cancer. There's a question, what resources do you recommend to get more involved in understanding deeper concepts of machine or deep learning? I think there's a lot of free courses online. There's also free textbooks. Um, Things like Udemy, Coursera, or these other online platforms we can learn these things are a great way to kind of dive in deeper and learn these concepts in machine and deep learning. I recommend just doing some research, getting to know these different concepts, and maybe taking an online course or a textbook, reading through a textbook, something like that, which can really get you more involved in deeper concepts. And again, there's also that class I mentioned that will teach you a lot about deep learning and computer vision. If we are interested in this field, is there anything you would suggest to do? Are there any internships or summer camps that you would suggest for high schoolers? That is a great question. Um, in terms of internships and summer camps for high schoolers um, in artificial intelligence, um, I'm not too sure on specific programs, but I know if you're interested in artificial intelligence and you have some knowledge or some passion, if you want to do a research internship, a lot of universities um, across the state, across the country, will take some high school students. You can always email the professors and ask them how you can get involved in their research or get involved in what they're doing with AI or deep learning. But in terms of actual names for programs, I can't recall any off the top of my head. If you'd like, you can send me an email and I can do some more research and I can email you back with some more internships or kind of summer camps. Any other questions? I think we have about a minute left to my session. Okay, I don't see any more questions. So I'll go ahead and wrap it up. Thank you everyone for joining my session today and just learning a little bit more about computer vision in medicine and diagnostics. Have a great day, everyone. Okay, there are a couple other questions. I'll get to those if we can. So let's see. What do you recommend for AI? Okay, there's another session starting. If you guys want to go over to that, you can. If not, I can just finish answering these questions. What kind of goals would you have? What kind of goals would the computer have to reach? What kind of goals would the computer have to reach to make it worth its while, so to speak? Um, could you restate kind of what that means? I don't completely understand what that question is. What do you recommend for AI in urgent care? If that question is kind of how I see AI being used in urgent care, I think it's just going to be one of these more general applications, either data analysis, computer vision, or some other application of AI in urgent care. But I think data analysis might be a great way to use AI in urgent care. They could look at patient history, geographic location, other metadata, and compile all those and build these more smarter profiles which will help these doctors or these medical professionals reach these conclusions or these diagnoses faster. And that's again another set of AI, if that answers your question. Okay, I'll just drop me the course registration link in the chat if you guys are interested in that, and then we'll go ahead and wrap up my session so you guys can get on to the other sessions. And there's quite a few exciting ones happening today. All right, then have a great day, everyone, and thanks for joining.